Okay, so here we are in our LabVIEW program, and what you're seeing here is the front panel of the program. Each LabVIEW program has two sections, or two windows. One is the front panel, which is what you see here, and the other one is the block diagram. The front panel is kind of the user interface of the program. It's where the user can put inputs and controls, and where they see outputs, which can be in the form of numbers or graphs or images, and a lot of other things as well. But in this program, we only have those three. So now I'm going to quickly show you the block diagram, and then we'll come back to the front panel. So here's the block diagram, and what we're going to do is we're going to zoom out so you can see the whole thing. So we go down here to navigation window, open it up, and so here is our entire block diagram. As you can see, it's kind of hard to follow if you don't know what's going on, and it's definitely a lot more complicated than the front panel, which is kind of the way it's meant to be, because this is where the actual programming happens. So I'll just walk you through this really quick. So in this portion right over here, this is called a DAC assistant. This is kind of the thing that gathers the data from the DAC box and the module that converts the analog to digital. Okay, and then down here, okay, then here is where we're converting strain to force. And I'm going to walk through this in detail a little later in a separate video. So we convert it to force, and then we get the force, and then we convert that to maximum normal stress, maximum shear stress, maximum strain, and maximum deflection. Okay, and I'm going through this really quick, but I'll go through it a little bit in more depth later. And so in this portion, pretty much this entire thing here is the alert system. And then, so for each of these systems, they each have to do with a particular case. So one of these is deflection, maybe normal stress, shear stress, and strain. Okay, so those are kind of the overall alert system areas over here. And down here is where we can write all the measurements to a file. And this part is where we are showing the model. So this is where the image is being called to be displayed. And so I'll explain this a little more later. So now we're going to go back to the front panel and walk you through that. So we go Window, Show Front Panel, and then we're back here. And so here's the front panel again. And so here is kind of the main portion of the program. Here is where you make your specifications. So here where you input the dimensions of the beam and the location of the strain gauges. So right now our base of the beam is 1 inch, and so on and so forth. And here are the various locations of the strain gauges, with the X value being measured from the fixed end of the beam and the Y value being measured from the center of the beam. So as you can see, it's half of the height, either positive or negative, depending on whether it's on the top or bottom of the beam. And so here we have to input the modulus of elasticity of whatever material we're using in our beam. So for our project, we used A36 steel, which is 29,000 kips for the Young's modulus, but we want to put that in PSI, so we have consistent units. In this portion is where we put the constraints. So whatever the allowable maximum deflection is, normal stress, and so on, this is where we specify those numbers. And we can also input a safety factor to just make it safer. So if you're not familiar with the safety factor, it basically just divides all these numbers by this number. So right now, the true allowable maximum deflection is really 0.1, because it's going to be 0.2 divided by 2. Okay, and so in the front panel, anything that has a white or a blank white background is an input, and anything that has kind of a gray or a darker background is an output. So here are kind of controls and specifications, and here are going to be numbers that LabVIEW is telling us. So as you'll see when I run the program, it's hooked up to the apparatus right now. You're going to see all these numbers start streaming in. And so as I apply a deflection, you're going to see right here that it's going to increase. Okay. And the reason you see they're kind of fluctuating a little bit, even though I'm not changing it, it's just there's just a little noise. Okay, and it's not too much. As you can see, the strain is really close, and this is in micro strains. And so, I mean, it's within 1 microstrain all the time, so it's not too much noise. Okay, so I'm going to stop that. Down here you can see graphs of the force and deflection versus time, and since they're linearly related to each other, they're going to behave in the same manner and follow kind of the same path. So as I apply a force, you're going to see right over here the force graph increase pretty immediately. And I'm going to let it down. And also on the deflection graph, you're going to see a similar thing, since they're, again, linearly related. Okay, so I'm going to let it back down. So you can see down here. And in this portion, you can specify where you'd like the data to be written to if you want to export it out. So right now it's set up to export to an Excel file, and that file is going to have 9 columns. And they're specified in the block diagram as to which column corresponds to which measurement. And so if we want to write to file, whatever numbers are occurring right here, are going to be written to the file. And so I'm going to write the file, and then whenever I want it to stop, I just click it again, it'll stop, and it's going to tell me where that file is, so I don't have to go searching for it later. And now we're going to go down a little bit in the front panel to the modeling portion of our program. In this portion of the program, we're going to see an image of the beam and the stress distributions along it, corresponding to this color scheme over here. So little to no stress is blue, and as you can see right now, we're going to turn the modeling on, so we're going to see what this. So right now there's basically no deflection being applied, maybe a little minimal one. It's going to tell us what the maximum stress is, and then so as I apply a deflection, you're going to see the stress distribution change along the beam. And so as I'm doing this, I'm going to start going a little bit faster, and as you can see, it keeps up with my motion. There's another video that shows this much better, but you can see it's very fast, and it gives a really good picture of what's actually happening. So now I'm just going to turn this off, just to kind of save the program. Okay, and also down here, it's going to show you where the image that's being called is coming from, or what the name of the image is, basically. Okay, and up here, see, you could see how I was fluctuating the beam right here. So I was going up and down fairly fast, right here as well. Okay, so now we're going to go up here, and this portion, the specifications for alert system, is where you specify how you want to be notified of the change, if it's or if your constraints are met or gone above. So here is where you so the way this works is the program needs access to an email account. So right now I just have it set up to access my USC account. So I just gave it my email, my password, and the server that it needs. And here is where you specify, like, to who is going to get the alert text message. And so you select their carrier. Right now I have it set up for 4 carriers: T-Mobile, AT&T, Verizon, and Sprint. That should cover just about anyone. And you can input your phone number. So pretty much any phone number that has those 4 carriers can be alerted with this system. And so right now I just have my phone number in there. And this is going to be the subject of the text message that you get. So we can change it to something else if we want, but right now just have this system alert. And so right now the alert system is off, which is good, because if let's apply maximum deflection of greater than 0.1. So right now it's greater than 0.1, and we didn't get any alert messages, which is good because it's off. So now I'm going to put it back down a little bit. So now it's below 0.1. So when I turn this on, it's not going to give us a message right away. But right after I go above 0.1, we're going to get a message on the screen, and I'm also going to get a text sent to my phone. So as you can see immediately as I reach 0.1, it's going to tell me deflection has exceeded the selected limit. it's going to tell me to inspect the structure. Okay, so that's basically the front panel of our program. The next video we'll talk about the block diagram.